Hello friends, welcome to Electrical Design Engineering YouTube channel. Today is the lecture. We will answer the question asked by the subscribers. If you have any question related to our free video course on design of transmission lines and distribution lines, you can ask it in a comment section or a Google form is given in the description. You can ask it there. Before starting the lecture, please subscribe the channel, like and share the video on your social media profiles. We are also going to start a new video course on Etap on this channel, which is also available free of cost. For that, you can join our WhatsApp group or a Telegram group given in the description. Today's question is, thank you sir for giving good information. Can you explain four conductor purpose which use in one bundled single conductor? Whether it means RYBN or any other reason for use four conductors as in one bundled conductor. Actually, the subscriber wants to know why we are using four conductors in a one bundled conductor or a three conductors in a one bundled conductor. That means whether that means they are RYBN. That means each conductor represents one phase or a different. This is the question based on the bundled conductors. Now, first of all, we will see what is the bundled conductor. When two or more conductors are used as a single phase, they are called the bundled conductors. As you see in the figure, three conductors are used here and they are used as a single phase. It will be R phase, Y phase or a B phase. And it is not that there are three conductors that one is R, another is Y, another third one is B. No, it will be R, it will be Y, it will be B. These three conductors act as a single phase, not three phases. Individual conductors are called the subconductors. You can see in the figure there are three subconductors in this figure. The individual conductors in a bundled conductor are called the subconductors. The subconductors are connected to each other at regular intervals by spacers. These are called the spacers. As you see in the figure, this is called the spacer. The optimum number of conductors depend on the current rating of the phase. Now, what is the advantage of using bundled conductors? Why we use bundled conductors? The bundled conductors help in increasing the current carrying capacity and reduce corona. There are two reasons to use the bundled conductors. One is the increasing the current carrying capacity. Another is to reduce the corona. Reducing corona. First of all, we will see how corona is reduced by using the bundled conductors. When power is being transferred at very high voltage using single conductor, the voltage gradient around it is pretty high and there are a high chance of formation of corona, especially in the bad weather conditions. By using several conductors instead of a one in a close proximity, forming bundled conductors leads to reduction in the voltage gradient and hence the possibility of the corona formation. Actually, the bundled conductors reduce the voltage gradient around the conductors. With the decrease in the voltage gradient, the possibility of formation of corona is gets reduced. Now we will see increasing current carrying capacity using bundled conductors. How the bundled conductors increase the current carrying capacity of the phase. Bundling of conductors leads to reduction in the line inductance. You know there are one is inductance, another is capacitance. By using the bundled conductors, the line inductance of a line gets reduced. We know the formula for calculating the line inductance is L equals 2 into 10 raised per minus 7 ln of GMD by GMR, where GMD is equal to geometrical mean distance and GMR is equal to geometrical mean radius. By making bundling conductors, the geometrical mean radius of a conductor increases. As the GMR of the conductor increases, the inductance of a conductor decreases. From the formula here, you can see the inductance of a line is inversely proportional to the GMR. When the GMR increases, the inductance gets reduced. By using the bundled conductors, the GMR gets increased. We can see how by using the bundled conductors, GMR gets increased. First of all, we can calculate the GMR of a single conductor. For a single conductor of radius r, the GMR is equal to 0.7788 into r, where r is the radius of a conductor. We will take a conductor, suppose whose radius is 18 mm, and GMR is equal to 0.7788 into 10 into 18, that is becomes 14.02 mm. This is a when one conductor uses as a one phase. That means when we are using a single conductor as a single phase, that we are not using the bundled conductor. Now we can use a bundled conductor. First, we will take two conductors in a bundled conductor. For two conductors bundled with distance d between the conductors, d is the distance between the conductors and radius is r. We will can take the same radius above conductor, that is r is equal to 18 mm. GMR is equal for two bundled conductors. GMR is equal to 0.8825 under root of r into d. That equals, let d is equal to 144 mm. Because the d is generally taken 8 to 10 times of the diameter of a conductor. And diameter of conductor is 18. When you multiply 18 by 8 or 9, or you can get 144, around that 144. GMR equals 0.8825 under root of r d. R is the radius of the conductor. We have taken the same radius, that is 18, into the distance between the two conductors is 144, that is 144, it becomes 44.93. Now you can see here the single conductor, the GMR is 14, but when two conductors are used as a single phase, as a bundled conductor, the GMR becomes 44.93. The GMR gets increased. Similarly, you can see when three conductors are used as a bundled conductor. For three conductors bundled with distance d between the conductors and radius r, GMR equals 0.923 cube root of r into d square. Let d is equal to 144, same d, whatever d you have taken here, same is taken here, and same radius 18 mm is taken also here. You can see the GMR becomes 66.45 mm. As the number of conductors in a bundled conductor increases, GMR gets increased. With the increasing of GMR, the inductance of a line gets reduced. What will happen when the inductance of a line gets reduced? What will happen? We can see this in a future video. By using the bundled conductors, the capacitance of a line increases. As the capacitance of line to neutral is given by formula C is equal to 2 pi epsilon divided by ln of GMD by GMR. You know, GMR with the increase of bundled conductor, with the use of bundled conductors, GMR gets increased. That means this term gets reduced. When this term gets reduced, capacitance of the conductor gets increased. With a decrease of inductance and increase of the capacitance, as here you can see in the figure, when this gets reduced, C gets increased, the surge impedance of the line decreases. The surge impedance of the line gets decreased. Surge impedance of a line is equal to under root of L by C. When L gets reduced with the bundled conductor, C gets increased. C is inversely proportional to surge impedance, and uh, surge impedance is directly proportional to inductance. Inductance gets decreased with the use of bundled conductors. With the use of bundled conductors, C gets increased. That is the capacitance gets increased. Net is that the surge impedance gets reduced. When the surge impedance gets reduced, as the surge impedance gets reduced due to bundling the conductors, the surge impedance loading of a conductor gets increased. That is current carrying capacity or a power carrying capacity of the current of a line conductor of a conductor gets increased. What is surge impedance loading? Surge impedance loading is equal to 1 by Z0. That is Z0 is the surge impedance. In the previous lecture, previous slide, in this slide, Z0 is the surge impedance. With the decrease of the surge impedance loading gets increased. Surge impedance loading getting increased means that power carrying capacity or current carrying capacity of the line of a conductor gets increased. With the increased surge impedance loading, the transmission capacity of the transmission line gets increased. Now it becomes clear to you what is the advantage of the with the bundled conductors, and how the transfer capacity or power carrying capacity of a conductor gets or transmission line gets increased with the use of bundled conductors. Thank you.